Okay, here's another vectors question for us, and we're told that relative to a fixed origin we have points A, which is negative 4, 1, 3, and B, which is negative 3, 6, 1. We're asked to find the vector equation of a line L1 passing through A and B. We're told about another line which is L2, which has the following vector equation. There's a point on the line, there's a direction of the line. We're asked to show the lines don't intersect and find the position vector of a point C on line L2 such that the angle A to B to C is 90. Right, let's give this a go. The first part, easy here. Let's draw a quick picture. Here's a picture. This is the point, let's say A, which is negative 4, 1, 3. This is the point B, which is negative 3, 6, 1. For a vector equation of a line, we need a point on the line and the direction of the line. The direction of the line is the vector A to B, which is this one, take away this one, so it's negative 3, 6, 1, subtract negative 4, 1, 3, which is going to be equal to 1, 5, negative 2. So the direction of the line is equal to 1, 5, negative 2. And we have 2 points on the line, so we just use the first point there. The vector equation of the line for 2 easy marks is R is equal to negative 4, 1, 3 plus lambda lots of 1, 5, negative 2. Of course, you can combine these, so it's negative 4 plus lambda, 1 plus 5 lambda, and 3 subtract 2 lambda, whichever way you want that to work. Okay, so I'm going to write the vector equation of this line up here in a green pen. The vector equation of the line is therefore negative 4 plus lambda, 1 plus 5 lambda, and 3 subtract 2 lambda. I might even take that with me onto the next page because I may need that. Okay, then we are given a new line. There's a new line there, and this has vector equation. If I combined it, R is equal to 3 plus 2 mu, negative 7 subtract 3 mu, and 9 plus single mu. And we're asked to show the lines don't intersect. So we're going to try and make these equal, and we're going to try and show that there are no solutions for this. So we're going to try and let 3 plus 2 mu on the one hand equal negative 4 plus lambda, equation 1, for the x's to be equal. We're going to let negative 3 subtract 3 mu equal to 1 plus 5 lambda for our second equation, and we're going to do 9 plus mu is equal to 3 subtract 2 lambda for our third equation. Okay, now what we're going to do here is we're going to take two of the equations, we're going to solve them simultaneously, or try to, and then we're going to show that it doesn't work in the third equation or there's some contradiction, etc. Okay, well, let me start by maybe taking these two equations here. Let me multiply this equation by 3. Okay, that way I will have 3 mu here and negative 3 mu here. So keep the negative 7 subtract 3 mu is equal to 1 plus 5 lambda, and I'm going to times this one by 3, so I have 27 plus 3 mu is equal to 9 subtract 6 lambda. Now I can add these equations because that will eliminate the mu's. So I'm going to add the equations here. These two add to 20, these two disappear, these two add to 10, and these two add to negative lambda. Okay, and therefore I can solve this, so I can add lambda to both sides and subtract 20, and I get myself that lambda must be equal to negative 10. Now, if lambda is equal to negative 10, I can work out mu from one of the two equations, therefore. So let's sub back into this one. Let's say here, negative 7 subtract 3 mu would equal to 1, and 5 times that would be subtract 50. Okay, so I've got negative 49 here. I add 7 onto both sides, so negative 49 add 7. I would get negative 3 mu equal negative 42. Divide by negative 3, I get myself that mu must be 14. Okay, so I found from equations 2 and 3, from 2 and 3, I found a solution that's lambda is negative 10 and mu is equal to 14. Now let's check in 1. Let's check they hold in 1. So 3 plus 2 multiplied by 14, well 3 plus 28, that's equal to 31. And on the other side, negative 4 add negative 10 is negative 14. So equation 1 does not hold. Okay, so therefore they do not intersect. No intersection. And we're done for that part. Now, let's rub this out. We know the lines don't intersect, and we know they are the two equations of the line. So I've got one line here, and I've got another line, let's say here. You know that they don't intersect each other. They don't have a point where they both meet. Okay, and this the first one is L1, and this one's here L2. L1 is 3 plus 2 mu, negative 7 subtract 3. Sorry, no, it's the other way around. Line 1, it's the green one. Line 1 here was negative 4 plus lambda, 1 plus 5 lambda, and 3 subtract 2 lambda. And line 2 over here was 3 plus 2 mu, negative 7 subtract 3 mu, and 9 plus mu. Okay, and you know they don't intersect. Find the position vector of the point C on L2, so some C is over here, such that A, B, C is equal to 90. Now A and B were 2 points on the line, so A and B were 2 points on the line, and they were negative 4, 1, 3, that was A, and B was negative 3, 6, 1. And you want A, B, C to be 90, so you want the angle A to B to C, that angle there, to be equal to 90 degrees. Now, we can dot, for them to be equal to 90, we have to find the vector BC. So the vector B to C is C minus A. So all we know is that it would be this take away this. So it would be 3 plus 2 mu, subtract negative 3. It would be negative 7 subtract 3 mu, subtract 6. And it would be 9 plus mu, subtract 1, which we can tidy up as 6 plus 2 mu, negative 13 subtract 3 mu, and 8 plus mu. So that vector there I have now found. That vector there is BC, and it's over here. Now if I dot that with the direction of this line, I'll get 90, and I'll find the mu that makes that true. So the direction of this line going back to L1, if you look at L1, we had the direction of that line as 1, 5, negative 2. So if we dot 1, 5, negative 2 with this vector BC, which is 6 plus 2 mu, negative 13 subtract 3 mu, and 8 plus mu, for there to be 0, I must get, for them to be at right angles, I must get 0. So 1 times this is 6 plus 2 mu, plus 5 times this, which would be equal to negative 65, negative 15 mu, plus this times this, which would be negative 16 subtract 2 mu, and that must be equal to 0. Now how many mu's have I got? 2 mu, take away 2 mu is no mu's, and then I've got negative 15 mu, so negative 15 mu. And then what numbers have I got? Well, I've got 6, take away 65, take away 16, so 6, take away 65, take away 16, I've got negative 75. And that must be equal to 0. Add 75 to both sides and divide by negative 15. I get myself that mu is equal to negative 5. So in this case, mu is equal to negative 5. So the point C is when I substitute a negative 5 in there. So it would be 3 subtract 10 negative 7 plus 15, and 9 take away 5, and that gets me the coordinates negative 7, 8, and 4, and that is the point C as required.